Hey guys, so in this video I'm going to be going through this basics of Numpy array portion of the introduction to Numpy section. And it's pretty lengthy compared to the last part of the section, so I'll probably be just breaking this down into multiple videos instead of just doing it all at once, because I ended up doing that initially and it was like an hour-long thing, so figured someone that wants to view this, it'd probably be easier to just do it in small chunks and several videos instead of just at one go. So in this section, or in this video, I'm going to be specifically looking at the attributes of arrays. So the very first part of this section, of this part, determining the size, shape, memory consumption, and data types of arrays. But as well as besides that, there's also this part of the section goes over indexing of arrays, slicing of arrays, reshaping of arrays, and joining and splitting of arrays. But like I said, these four things here, I'm not going to be doing until a later video. So for now, in this video specifically, I'm just going to be looking at the attributes of arrays. And yeah, I guess that's it. Let's start that. So we're going to import Numpy, of course, as NP. And get that in there. And now we're just going to create some arrays, pretty much. So we'll do that. And, we'll do the seed here. And I'll tell you what the seed means right now in a sec. But let me just start by doing this. So I'm just going to make a one-dimensional array on this x equals 1 here. Actually, let's just do it in one thing here, and then we're going to make another array here, but this time a two-dimensional one. So this thing, and size equals 3, 4, and then we'll do a three-dimensional array as well. So we'll do np.random.rand int 10 size equals, let's do 3, 4, 5, and again these are examples from the book there. And really what this np.random.seed does is it allows for basically these arrays here to stay consistent the whole every time we call this piece of code here. So the values that we get for x1, as long as we have this seed here, are going to stay the same. So they're not going to change. The values are always going to remain whatever they are. So for example, let's see, if I didn't call that seed there, so np.random.randint and do 10, and then that's without the seed, we'll get 4. But if we copy and paste that line of code here, we get 3 this time. So it changes every time, and really the seed makes it so that it doesn't change. So if we were to do the same thing here, let's do np.random.seed, and this time let's say we put a seed there, and this number could be anything, so we'll put a 4 there. So this 4, the parameter 4 there with the seed, you can really change that 4 to anything. It's just a placeholder for this code. So watch, we got 7 this time. Oh, I was like, what the hell? But we have to call the seed again. So we have to call the seed and the same number on the seed, and we get 7 again. So since we called the same numbers for the seed here, this value is going to stay the same since this line of code is exactly the same as this one. Let's see if we change that. Yeah, so if we change the seed there, it's going to change the value here to 8, not 7 there. So let's go back to 4, and we get 7 again. So that's really what the seed does. So in this case, our x1, x2, and x3 are always going to stay the same because we got that seed set initialized there. But anyway, moving on from that, we got, let's look at the x1 and all that. So we got a one-dimensional array here with x1, and that's all these are pretty much the same thing. So np.random.randint gives us an array of random integers. The first parameter 10 for all of these 3 is just going to make it so the numbers here, the values of the array, are going to be between 0 and 10. So we're not going to go past 10 there. and then the size of the array here. So in this case for x1, size equals 6. So we got 6 values here and a one-dimensional array. Let's do, and look, since we got that seed here initially, if we call x1 again, it's going to be the same exact thing. But let's look at x2 now. So in x2, random.randint, so random integers between 0 and 10. This time with the size matrix of 3, 4. So a two-dimensional array here of 3 rows and 4 columns. And then x3, what is that? So random.randint between 0 and 10. And this one is a 3 by 4 by 5 matrix. So it's a three-dimensional array on this x equals 3. So we got, see, it's 3, 4, 5 here. So 1, 2, 3 is that first number. And then 4, so the number of rows, 1, 2, 3, 4. And then that 5 up here, the last number there, is the number of columns, 1, 2, 3, 4, 5. And that's our three-dimensional matrix there. And then each of these, each array has certain attributes that you could call. For example, x3, let's use that. And these are just from the book, so we got x3.enddim. That's going to give us the number of dimensions. So since x3 is three-dimensional, it's going to give us the output of 3. But if we do it on x1, so that's a one-dimensional array, remember that, should be, oh, I forgot the m there, should be 1, and x2 should be 2 since it's a two-dimensional array. So we got that. And then, so that's .ndim for number of dimensions there. We could also do something like x3.shape, and we got 3, 4, 5. So that's just the size of each dimension there. So the size of the first dimension is 3, second dimension 4, and then 5. Sorry. So if we do it on x2.shape, we get 3, 4. So that's the size of the array for x2. And then remember that 3, 4 is what we put for the size there anyway, so it makes sense. Same thing with x1. 6. So we only got size 6 there. One-dimensional array, so that makes sense there. What else could you do? You could do x3.size. So 60 in this case. That's just the total size of the array. So we got 60 for x3, but if we do it for x2, it should be smaller. And next one should be even smaller than that, since it's a one-dimensional array. So 6, 12, 60. What else can you do? You could do, oh, we already saw this one here, the data type of the array. So x3.datatype. Got that integer. We could set the data type for each array too, as we saw in the earlier video. So here you could do like dtype equals, and then do it here again. No, it was already an integer. Change it to a float. Oh, we can't do that because they all have to be the same. Duh. It's an integer. We set it as integer, so just ignore I did that there. But yeah, that's really how it works. And then that's really just the first part of this section here. So we looked at that, the random seed there, that just, it's a seed for reproducibility. We got the one-dimensional array there, two-dimensional array there with x2, and then three-dimensional with x3. And then we saw here each array has these attributes here. So number of dimensions, the size of each dimension, and the total size of the arrays. So pretty easy stuff there so far. And then the next video is going to be about indexing single elements out, and I'll probably do that along with array slicing or accessing subarrays from that. But if you want more like information of the attributes of NumPy, you could just I'll link this on the description. But this this website here or whatever, it's just pretty much the NumPy site, and you can see all the different attributes here. So these are the different ones, buffer, data type, and all that here. But really, all of these, you probably won't need a lot of these. So that's why they only gave us a couple of examples, like shape here, or what else did they give us? Size, data type, things like that. But for a lot of this stuff you probably won't need, but if you did want to look at it, I'll leave it in the description, like I said. And yeah, well, that made a little bit of sense, but yeah, thank you.